So in 8.5, this is sections 8.5 through 8.9. In 8.5, we did the distributive type with the greatest common factor. If you get greatest common factor, that's always going to be 2 or more terms. Okay, and you can see an example of that. I'm not going to focus on that right now. Grouping, there's going to be 4 terms, so it's kind of a common factor deal. Only you got 4 terms and they don't all have a common factor. But if you split them up into 2 groups, each group has a common factor, and then each group has a common parentheses. So again, I won't go through that. Trinomial factoring, obviously if it's trinomial factoring, that means it has 3 terms. I probably should have written that in there. Now that doesn't, remember, all of them, 2, 3, 4, 5 terms, it doesn't matter. It can always be done with greatest common factor or distributive. Okay, but trinomial can only be done if there's 3. So I gave you 3 examples here. Let me switch papers here. This third example is the new lesson. 8.6 is like example 1. 8.7 is like example 2. And then 8.9 is example 3. So what we're going to do today is this part right here, perfect square trinomial. Okay, now just real quick, notice that what has to happen if it's a perfect square trinomial, obviously, first of all, it has to have 3 terms. It has to be a trinomial. The second thing that has to happen is that this first term and this last term must be perfect squares. If they are not, it's not a perfect square trinomial. Now, it may be a regular trinomial, and we do it more like this up here, like we did in 8.6. But if it's a perfect square trinomial, notice that the square root of this goes here and here, and the square root of this goes here and here, and the 2 parentheses end up looking exactly alike. Okay, on a perfect square trinomial, the 2 parentheses are going to look exactly alike, which means x plus 3 times x plus 3 is the same thing as just saying x plus 3 squared. Okay, and then in 8.8, we did difference of squares. Like if you had n squared minus 49, that was n plus 7, n minus 7. The only way you can do difference of squares is if you have 2 terms, there's a minus sign in the middle, and there's 2 perfect squares. Okay? This is an example of when you have more than one type of factoring. So I'm not really going to even refer to this sheet because what we're doing today, this part here, is pretty easy to pick up on. You're welcome to refer back to that sheet as much as you need to. Let's go right to the homework. We are on page 526. And we're going to start with problem number 1. And the instructions say determine whether each trinomial is a perfect square trinomial. You'll write yes or no, and if it is, if yes, then factor it. If it's not, we're just going to say no. Okay, so number 1, it says 25x squared plus 60x plus 36. Okay, so the question is it a perfect square trinomial? And to answer that question, first of all, it has to be 3 terms, has to be a trinomial. It is. This has to be a perfect square. Is this a perfect square? Is 25 a perfect square? Yes, 5 times 5. X squared is x times x. And is this a perfect square? Yes, 6 times 6 is 36. Okay, so that means there is at least the possibility that this is a perfect square trinomial. It is not automatically. Okay, because what we have to do is we have to now factor it. And if it's a perfect square trinomial, then I know the square root of this goes here and here. So the square root of 25 is 5x and 5x. I know I want it to be plus and plus, because if that's positive, it's either going to be plus plus or minus minus. And that tells me which. And then I want the square root of this to go here and here. Because if it's a perfect square trinomial, these should look exactly alike. 5x plus 6, 5x plus 6. Now, is it really, does that work? I got to test the outer and the inner. So the outer gives me 30x, and the inner gives me 30x. And if you add those together, it must equal this right here. And it does. So this was a yes, and this is the, oh, wait a minute, sorry. We want to write it this way. Get in the habit of writing it this way. I won't count it wrong if you write it this way, but if it's a multiple choice test, they're going to put it like this. Number 2. 6x squared plus 30x plus 36. Is that a perfect square trinomial? Is it a trinomial, Yamara? Yes. Okay. Second thing we're answering is, are these two things perfect squares? So is this a perfect square here, Yamara? If you put square root of 6 in your calculator, does it come out even? No.
How do you do the square root in the calculator?
It's this button right here. You see the little blue? Okay, so it's second and then that x squared button. Okay, so this is just simply a no. If it's no, we don't have to factor it. This actually can be factored other ways. There's a common factor, and then there's a trinomial that's just a regular trinomial, but it didn't ask for that. So just no for this. Number 3, it says factor each polynomial if it's possible. If it's not possible, then just write prime. So cannot be factored, non-factorable, prime, all that means the same thing. So number 3, we've got 2x squared minus x minus 28. So first of all, let's just real quick decide if it's a perfect square trinomial. Haley, is this a perfect square trinomial? Because square root of 2 doesn't come out even. I know it's tempting to say it's 1 times 1, but it's not. So it's not a perfect square trinomial. So we got to ignore what we're learning today. We're going to ignore that. We're going to look at the other types of factoring. So Haley, is it common factor, the first type? Is there a common factor anywhere in here that I can divide all these by? So all 3 of these can be divided by 2? Not the middle one. Okay, so no, there is no common factor. So it's trinomial. It's not difference of squares because it's not 2 terms. So if it's trinomial, then what would I put here and here, Haley?
X and X.
Well, x times x would only be x squared, wouldn't it? So I need one of them to have,
1.
no, yeah, 2. Now you said 1, like 1 and 1 would give you 2, but remember you're multiplying, so 1 times 1 would not be 2. Yeah, and just keep in mind whenever that x squared has a number in front of it other than 1, it's almost always going to be 2xx, 3xx, 4xx, 5xx, you know, depending on what you have. Okay, what are the signs going to be here, Valerie? 1 plus, 1 minus, because that's a negative. If the last term is negative, it's 1 plus, 1 minus. Okay, Valerie, what are all the combinations that would give us 28?
1 times 28, 2 times 14, 4 times 7.
Okay, and so we'll just go right up the list. We'll do 4 and 7. And remember, the only way you can tell if that's the right combination is to test it, the outer and the inner test. So Valerie, what does the outer give you?
Negative 14x
And
plus 4x.
and does that give you negative 1x?
No.
Okay, so then it might be that we just need to switch the 4 and the 7 around. So 2x plus 7, x minus 4, and that gives you
Negative 8x plus 7.
and does that give you? what you're wanting? Negative 1x. It does. So negative 8 plus 7 is negative 1x. It needs to equal this. So this is the way you factor it. But again, remember, that was not perfect square. What they're trying to get you to see is that sometimes they are perfect square trinomials, but it's not going to be like a whole bunch of perfect square trinomials, and that's all you're going to see. Sometimes it will not be, and you've got to try to factor it a different way. Okay, number 4. You got 6x squared minus 34x plus 48. Chase, is this a perfect square trinomial? Square root of 6 does not come out even, and neither does 48. Oh, and also, for it to be a perfect square trinomial, that last term has to be a plus. Because remember, if it's a perfect square, let's say it's minus 36, what times what equals minus 36? 6 times 6? Negative 6 times negative 6 equals negative 36? See, it cannot be a minus here at the back. If it's a minus, that by itself, that's the easiest. I got a minus on the last term. That's not a perfect square trinomial. Okay, so this one's not either. So Chase, that means we can't use perfect square trinomial factoring. Is there a common factor? They can all be divided by 2. They can all be divided by 2. So if we factored a 2 out, dividing each of these by 2, we get plus 24. Okay, so now I have a trinomial that I'm going to see if I can factor that. Okay, so Raiden, what would you put here and here? 3x and x. What are the signs going to be, Raiden? Minus, minus. Negative, negative. Because if the last one's positive, it's either plus, plus, or minus, minus. This tells me which. And then what are the combinations that'll give me 24, right? 3 times 4 is 24? And 4 times 6. Okay, so if we just start at the bottom, 4 and 6, right? And does that work? The outer gives me negative 18x, and the inner gives me, and if you add negative 18 and negative 4, does it give you what you're looking for? No. So let's switch them around. Maybe I just got them backwards. 3x minus 6, x minus 4. Okay, does that work, right? Sorry, 6 here, 4 here. Okay, so this gives me, and does that add up to be negative 17x? That did not work. So 6 and 4 is not the right combination. Let's try 3 and 8. So 3x minus 3, x minus 8, and what does that give me, outer and inner? 24x. And does that add up to be negative 17x? So that didn't work, so let's switch it around. And that gives me negative 9x, and does negative 9 plus negative 8x give you negative 17x? So that is the combination that works. Now, and once again, I know we're learning about perfect square trinomials, but this is what we learned back in 8.7, where you just do regular trinomial factor. Okay, number 5. You've got 4x squared plus 64. So Stephanie, is that a perfect square trinomial? So first of all, is it a trinomial? Are there 3 terms? Now there's only 2 terms. So it's not perfect square trinomial. We can ignore that. So is it the difference of squares? There's 2 terms. Is it the difference of squares? If it's the difference of squares, it has to be 2 terms, and it has to be a minus in the middle. Is it the difference of squares? No. So the only thing left that I can really even try is common factor. Is there a common factor? What would that be? 4. They can both be divided by 4. So if you divided them both by 4, inside you would have
X2 plus 16.
okay, and can x squared plus 16 be factored? No. When you have 2 perfect squares with a plus sign in the middle, you can do nothing with it. I know it's tempting to think it's x plus 4 times x plus 4. It is not. Okay, number 6. Okay, is this a perfect square trinomial, Yomara? So is 4x squared a perfect square?
No.
Square root of 4 doesn't come out even? It is. Is negative 16 a perfect square?
What would I do to find out if it's a perfect square?
Square root of negative 16? You know how to do square root sign on the calculator?
Yeah. So I'll put negative 16 is
No, you would do this. This button right here, where my finger is, has a little, the right above it has a little blue square root sign. You're going to do square root of negative 16 and enter. And you get error. Yeah? Did you get error? That means you can't, no negative number is a perfect square. You cannot take the square root of a negative number. So it's not a perfect square. So is this a perfect square trinomial? No. Okay, and then I'm going to save us time. It's a trinomial, so we could do normal, regular trinomial, and you can see there's lots of combinations that we could test. I'm just going to help you out and say none of them are going to work. So if none of them work, that means the answer is what, Yomara? Say again? Well, if you're factoring it and it cannot be factored, starts with a P. Look in the directions. In the homework directions. For 3 through 6, what does it say up there? If it cannot be factored in the homework. Not the notes, the homework itself, in the book.
Oh, you write
Prime. Now again, you would not know it's prime until you tried all the different ways to factor trinomials. I just didn't want to take that time to do it because there's lots of combinations we'd have to go through. It's prime. Okay, number 7, we have 4x squared equals 16. Okay, so I'm going to show you 2 ways you can do this. Now, if you will recall, the first way, this is the way we did the earlier.
36.
36, sorry. 36. If you'll recall, whenever we have an x squared and an equal sign, we want it to be equal to 0. So we want this 36 to go over here, which would make it 4x squared minus 36 equals 0. Then we're going to factor this over here. Okay, now, is there a common factor here? Can these two terms be divided by a common number? 4. And if we divided each of them by 4, what would that leave inside the parentheses? X squared minus 9. Then this is the difference of squares, so how would that be factored, Valerie?
If it doesn't have a number in front of it, would it just be x, and then it, since it's behind the sign, would it be a plus and a minus?
Correct. But even more specifically, the difference of squares, you just have two terms, and you have a minus sign, and they're both perfect squares. You put the square root of the first one here and here, you put the square root of the second one here and here, and that is
The square root of the second one?
square root of the 9.
Oh, 3.
3 and 3. Okay, so now I've got it factored. So now I'm going to set each factor equal to 0. So if I move the 3 over here, it'd be negative 3. And move the minus 3 over here, it'd be positive 3. And you say, well, you just ignored that 4 over there. Shouldn't you say 4 equals 0 also? Well, first of all, 4 is not equal to 0. Secondly, if it has an x, like if that said 4x there, then yes, I would say 4x equals 0. Divide by 4. 0 divided by 4 is 0. But it doesn't have an x. If it doesn't have an x, I ignore this out here. This is a factor, but it's not a factor that contains x. Okay, let me show you a different way you could have done this. You can write both these down. You can watch, whatever you're going to do. So I'm going to do this more like regular algebra. If there's only an x squared and there's not an x squared and an x, if I got more than one kind of x, I can't do this. I can only do this if there's only an x squared. I can solve for x squared, meaning I'm going to get rid of 4. So I get x squared equals 9. Then to get rid of this square, I'm going to square root both sides. Because a square and a square root cancel each other out. Now, I also have to put plus and minus over here. Square root of 9 is 3, but it's positive 3 and it's negative 3. And you say, well, I thought square root of 9 was just 3. Well, if you put that in the calculator, that is what you're going to get, 3. But keep in mind, if I had x squared equals 9, isn't it true that negative 3 squared also equals 9? Right? Negative 3 times negative 3 is 9. If I have 3 squared, it's equal to 9. So there's really two different numbers that are going to work, the positive and the negative. That's why we put that plus and minus here. Okay? That later on, that's going to kind of become an important concept to be able to do. But for now, if you understand this better, feel free to do it. You can see this is a little quicker. Okay, number 8. 25a squared minus 40a equals negative 16. Now notice there's an a squared and an a, so I cannot do it this shorter way, like I just showed you. So it's got an a squared, so that means I want to send this negative 16 over here. And it's going to become plus 16. And then I'm going to have equals 0. Okay, so is there? So now we're going to factor. Is there a common factor? No, there's not a common factor. There's nothing you can divide them all by. So now it's not a common factor and there's 3 terms, so the only kind of thing I can do is trinomial factoring. But it might be perfect square trinomial factoring, because if it is, that's a little easier to do. It's an A there. Is this a perfect square? Yes, 5a times 5a. And is this a perfect square? Yes, 4 times 4. So I'm going to assume that it might be trinomial factoring. So I'm going to put 5a here, 5a here, and I'm going to put 4 here and 4 here. And then what are my signs going to be here? When that's positive, it's either plus plus or minus minus, and this tells me that it's minus minus. Now, I only know for sure if this was accurate if I do the outer inner test. So the outer gives me negative 20a, and the inner gives me negative 20a. Does negative 20 plus negative 20 give me negative 40a? Yes. So now you say, so now I'm going to take each factor and set it to 0. But notice the 2 parentheses are exactly alike. So I'm going to get a duplicate answer. That's called a double root. You don't have to worry about that right now. That'll come into play later. When you get a duplication, that's called a double root. But for what we're doing, if it's going to be exactly the same, I only really need to do one of them. So 5a minus 4 equals 0. Add 4. That would bring the 4 over there to be positive 4. Divide by 5. And a equals 4/5. And that's my answer. Okay, number 9. Okay, can we do the shortcut way, or do we have to do the long way and make it equal to 0? If I got a y squared and a y, I got to do it the long way. I got to factor. So I don't want it to say equal 9. I want to say equal 0. So Chase, what do I do to get that 9 to turn into a 0? Okay. Yeah, I'm going to put minus 9 with the 18. So then that will be 0. So what would that become then, Chase?
It would be 64y to the second power minus 48y plus 18 minus 9 equals 0.
18 minus 9 is equal to
So, it would be
9. Okay, so now I'm ready to factor this. Is there a common factor, Stephanie? I'll always take the smallest number, think about all the numbers it can be divided by. Can everything else be divided by that? There is not. Because the only thing you can divide 9 by is 3 and 9. That cannot be divided by 3 or 9. Okay, so it's not a common factor. It's not. I can't use the distributive property thing. So it's a trinomial. Is it a perfect square trinomial? Is it a perfect square trinomial here, Haley?
Yes.
What would I put here and here then?
Um,
What's the square root of this?
8y.
8y and 8y. And then the square root of this over here would be, square root of that is 3 and 3. And then what are my signs going to be, hey? When the last one is positive, it's either plus plus or minus minus. Yeah, so it's minus minus. Now the temptation is when you see 1 minus and 1 plus here, you think there should be 1 minus and 1 plus here. That's not the way to look at it. You only look at the last number, and that determines whether it's going to be plus plus, minus minus, or 1 plus 1 minus. Now the middle one will tell me whether it's plus plus or minus minus. Okay, so once again, just like the previous problem, we got the two factors look exactly alike, so I really only have to do it once. 8y minus 3 equals 0. If I send minus 3 to the other side, it becomes positive 3. And then I divide by 8. And y equals 3/8. That could be turned into a decimal. I'm not 0.375 or something, but I prefer a fraction. Okay, number 10. Okay, I'm going to do this the short way because notice that there's only z. I don't have a z squared and a z. I just have a z in parentheses with the square. So does anybody remember how we get rid of the square?
You square
Put
like 2.
the second power to whatever's in the parentheses and add if there's a power in the parentheses.
Well, there is a second power. What'd you say? You do the square root of it. This and this cancel each other out. But remember, I have to do it over here too. And when I do it over here, I have to put plus and minus, meaning there's two answers that are going to come out of this. So if this and this cancel each other out, that leaves me z plus 5 equals positive square root of 47 and negative square root of 47. Now we're just going to, you say, well, I'll put square root of 47. It's going to be a decimal. Just don't do it right this second. So then I want z by itself, so I got to subtract 5 from both sides. So my answer would be negative 5 plus square root of 47 and negative 5 minus square root of 47. And if you then did that, you take your calculator, the two decimals, and I'm going to just tell you right now, sometimes the answer on a multiple choice test is going to be this right here. And then sometimes they'll put it in decimal form. If they put it in decimal form, if you said negative 5 plus the square root of 47, you're going to get 1.86. And if you did negative 5 minus the square root of 47, you're going to get negative 11.86. Okay, so this is, so for my sake, I will take it either way. But if it were a multiple choice test, it could be written either way. So you'd need to know that if it's in decimal form, you got to actually split this. And again, does everybody understand that this means negative 5 plus square root of 47 is one of the answers? That's where the 1.86 came from. And then negative 5 minus the square root of 47 is where the other answer came from. Okay, that's what that plus or minus means. Okay, number 11. This is a very common problem. We've already done it once, but I just want you to keep seeing this because you are going to see this on the test. You'll see it on my test as well. Okay, so if you'll remember, this h sub 0 means the initial height. This h is just generally height, like if you can find the height. When was it at the height of 15? When was it at the height of 10? When was it the height of 5? When was it the height of 0, which is when it hits the ground? So this problem says that while painting his bedroom, Nick drops his paintbrush off his ladder from a height of 6 feet. So if it starts out at 6 feet high, where are we going to put that? We're going to put where this h sub 0, that little sub 0 means that's the starting height. Okay, so we're going to put negative 16t squared, and we're going to put 6 here. That's where it started. And then, okay, so then it says approximate the number of seconds it takes for the paintbrush to hit the floor. What's the height when the floor hits, when you get to the floor, what is the height? 0, right? So we're going to put that over here. And then now we're gonna figure out where it hit the ground. So this, if you'll remember, we did this earlier on this kind of a problem. We want to know where it hit the ground. So what we're going to do is we're going to come to y equals, and we're going to put that in the calculator. Now notice you cannot put t squared in the calculator. Yeah, actually you can, but the calculator won't understand that. It's got to all. If you're gonna go to y equals, you always have to use x. Okay, so that should be in the calculator, and then you want to go to zoom 6, and it looks like this. And so, so remember, where does it hit the ground? It hits the ground right here. Because remember, it started up here at 6, and then it hit the ground. You say, but it shows that it keeps going. Well, that's theoretically it could keep going, but the floor is going to prevent it from continuing. So it's going to stop once it gets right here. That's the point we want to know. So the easy way to do this is just simply to hit trace and then move it down here close and then zoom in. So go to zoom, number 2, zoom in and hit enter. And now it'll zoom in closer and we can get a little better read on it. So hit trace again. And remember, we want to know how much time, that's the t, only we put x instead of t, so the x value is what we want. Now, we're not right at a height of 0, but if you were rounding it off, where would you be? If you were rounding this off to the tenths place, would it be 0.6, 0.5, 0.7? What would it be if you rounded it off? Everybody should be saying this at one time. This rounds off to what? 0.6. Okay, well, you say, well, that's not, let's go back one where I'm just above it. What does that round off to? Yomira, what does that round off to?
Which one is that?
The x. The x value right here. What does that round off to? 0.6. So both of them, when I went as a little bit above, it rounded off to 0.6. When I went a little below, it rounded off to 0.6. So approximately 0.6 seconds is how much time it took for it to hit the floor. 0.6 seconds is how long it took to hit the floor. Now you could have also, you could have factored and you could have set it equal to 0 and all that kind of stuff and then found it that way too, but this is a pretty easy way to do it on the calculator. Okay, continue there doing odds.